Hello? Hello, hello? I am here. I assume you can hear me. I'm just testing right now. Okay, so I think we're gonna go ahead and get started for today. Yeah, please post in the chat if you have any issues. There's also a couple, Elvita and Brianna, are with me here to answer any questions. So just whatever questions you have, feel free to drop it in the chat. The way tonight's talk is going to work is that first I'm going to spend about like 10 to 15 minutes going through a little bit of a background, and then we're going to switch over to a lab which we will run with Google Collaboratory, and we're going to add that link to the channel in a bit. It should also be on the meetup, but I'll have a slide later where I also explain how to open it. So yeah, so yes, and I will also introduce myself in a second, but I guess to start with the talk for today, we're going to be talking about SpaCy, which is a really great natural language processing library. And if you're not very familiar with natural language processing, I will also in my introductory slides go through that a bit. But also to bring it back, like, what is WWCode? I'm part of the WWCode DC chapter. It's all about supporting women and collaborating with other women. We have 1 or 2 meetups every month. We also have a very active Slack channel, which there's info for here, and you could probably look it up pretty easily later. So that's just a bit of intro to the group. And now I guess I'm going to introduce myself next. Sorry, wrong screen. So yeah, so hello. My name is Anastasia Kornilova. I'm a data and research scientist at a company called Fiscal Note, where I work doing a lot of different natural language processing and machine learning analysis on different data, like legislative and regulatory data. We help people and organizations connect to their government. You can find me on the DC Slack, but just by typing my full name, because there's only one, Anastasia. I also have a Twitter, which I post on very rarely, and a website which has records of some of the previous talks I've given, because I love to talk about this sort of stuff. So before we get started further, just again, a reminder about housekeeping. So if you have any questions, post them on the Twitch, and I'll share it now really quickly that we have a link where you can essentially make a copy of this Python lab, and the idea is you'll be able to run it kind of on your own copy of it. So yeah, and we'll get to that in about like 10 or 15 minutes, but if you wanna try to pull it up on another screen, you can go for it. So kind of like, what are we going to do today? Today we're going to talk about some use cases for natural language processing, kind of go through what that is and why SpaCy is so great for that. And we're also going to go through just some like very basic properties of SpaCy. And finally, we're going to talk about some cool features you can build with this library. So those are the goals for the lab. And I guess I also wanted to give a couple more examples of what I do at my work, so we can go through like kind of how it will tie into machine learning and natural language processing. So as I mentioned, I do a lot of work with legislation and regulation. So one of the things I worked on was building a model to predict which legislation in the US as well as kind of across different states will pass. And for that, we build models using information about people. So like computed features about like who's in the party in power, like how effective is the sponsor, but also we use the text of the bill because certain subject matters may or may not pass, and that kind of text classification is one of the aspects of natural language processing. I've also worked in some more traditional natural language processing tasks you might be familiar with, like using statistical methods to compute kind of keywords for a document that they can essentially be used like hashtag or tags, and also helped build a big policy taxonomy where we started with some kind of linguistic and essentially like library scientist specialist people, but then we were able to verify a lot and expand it using natural language processing. So I will kind of refer back to these examples throughout the lab, but that's kind of a high level about me. So what is natural language processing? Well, in a sense, natural language processing is just any sort of computer stuff dealing with text. It usually involves machine learning or statistical methods, but technically it doesn't have to. It's just usually when people say natural language processing, it's about computers and text. And if you can think about it, Siri actually involves like at least several different natural language processing tasks, like computing audio, which is just like waves into words, then being able to like find a question in those words, finding an answer to that question, and finally also producing kind of answers in kind of like a natural language processing way. So there's lots of different natural language processing tasks going on here. SpaCy kind of is more low level. It won't help you with a lot of those advanced steps, but it will help you with some of the basics. And while natural language processing can be really fancy, there's also a lot of simple applications. Like I like to use Todoist to manage like my tasks, and as you're typing, if it recognizes a date, it will offer for you to tag that date automatically. And in a sense, doing that recognition on text is still a form of natural language processing. So, any questions so far about anything? Always happy to just answer, even if they're towards the end. I'll make sure plenty of Q&A time to also answer any kind of more general questions about data science and, I guess, my career path. So, again, I alluded to the fact that SpaCy helps with some kind of more lower level tasks, and so a lot of it's almost like linguistic things. So, a couple of concepts in English linguistics are parts of speech tagging, where each word, as you might be familiar from school, is like a noun, a verb, an adjective, and being able to automatically tag those for a computer is non-trivial because computers don't really have linguistic knowledge. So one of the things that SpaCy does for us is parts of speech tagging. And then another one, as you see these arrows on top, they tell you how the words relate. So the word cancel, this noun of that verb is rose. So this is like all great and linguistic-y, but how might this actually be useful? Well, again, you might only want to pick the noun phrases, and in order to pick noun phrases, you need to know what adjectives are, what nouns are, and then like which adjectives and nouns go together. And again, I was alluding back to that kind of keywords application we had, and for that, I actually had to only pick out the noun phrases. So I ran for SpaCy, and I only found the noun phrases, and then I did some kind of counting statistically based techniques, because I didn't want to take every single pair of words, because like this is that's not a really useful keyword even if it appears a lot. So this is one way where I actually was able to use SpaCy's ability to find noun phrases. And so for example, of some of those phrases, like we do a lot with legislation, so I was looking for like the CARES Act that came out this year, and by looking at just noun phrases, I was able to get some nice phrases like clinical nurse specialist and covered small business. So again, being able to find those nice phrases and know your kind of linguistic knowledge of what makes nice phrases, it can be very important. So the next thing that's very important that SpaCy does is named entity recognition. And named entities are essentially anything that represents like a real life concept in text. So like the name Anastasia Kornilova, a date Thursday, I used the slide in another talk I gave, Women Who Code an Organization, and Washington being a place. And why this is helpful? Well, it lets you, again, tag things like the way that Todoist thing did. So if somebody typed it in, you could be like, would you like to tag Anastasia? Or would you like to set a reminder for Thursday? And we're actually doing some of this stuff to improve kind of an actions feature we have in Fiscal Note, and to basically be able to better extract that sort of information. So again, named entity recognition can be very helpful. And finally, we have not covered in this lab, but I know we had a lab a couple of months ago that you can find on GitHub. The topics we talked about there were like sentiment and topics. So text classification is a task where you'll predict if the text is positive or negative. So for example, you want to know like, are people saying good or bad things about your product in their reviews, or you want to categorize things by types. And even here, again, knowing those kind of like nouns and stuff is important, because you might only want to find the adjectives that talk about like a specific type of noun in your text, and SpaCy really helps for that. And actually it has like a module which will let you train a natural language processing model. So like instead of using like another lib like scikit-learn, they have a built-in one, but we're actually not going to have time to go through that today. So like, what is SpaCy? What does SpaCy actually do? Well, it's kind of like a library that contains algorithms for doing NLP tasks. So again, that parts of speech tagging, named entity recognition. It also has like models trained on multiple languages. So it's actually already did that work of preparing the labeler. And it has then a framework you can extend. So you can start with like the English model and then train a custom version of it that better matches your data. So we had to do that for some of our very like legislation related applications because it didn't really match the default library. So when it runs, essentially, like you start with text. So in Python, that's just a string. And all of SpaCy is kind of wrapped into this NLP class we'll be using. And finally, it outputs an object, which in this case is just called doc, and that's just like a special Python class. And then here we have those tasks, and they're done both using like huge machine learning models and neural networks, and also some special rules created by linguists. And essentially then what you essentially do in your code is you start with kind of like loading the model, then you have some text, then you create the doc, and essentially for most of the lab we'll explore the properties of this document. And again, to quickly just touch on what the model is, we start kind of with the language English, which is used to determine kind of how to tokenize the text, put into words, as well as some other basic properties. Then the model's core web talks about where did the data come from. So mainly you'd use data from like Wikipedia and a bunch of random other websites. And finally, small refers to the size of the model. So essentially when you're like building an application, you have trade-offs where like you can be very accurate, so you find all the named entities correctly, but you might have to take up like megabytes of space, and depending on where you're running the model, that might not be feasible. So they have models of different sizes like that. So this is kind of like the high-level overview, and I'll be going through this, like kind of repeating some of this when we start in the lab. So yeah, so this is kind of where we are so far, and I'm going to give you guys a minute to get the collab part set up, and then we can switch over to that. Yeah, any questions though for now? Let me find which tab I had it open in, apologies. So yeah, the one thing you want to do is you want to run the first 3 kind of like cells by just clicking like Shift Enter, and then when the text part stops, we can talk through it a little more together. Is the resolution of my code okay? Can you guys see it? I mean, I know you probably will have it on your own screen as well, but it can be helpful. I can also zoom in on the screen. Yeah, I'll just give you guys one more second. I was really excited when I found the cat feature. I really like cats. I think they also have corgis, supposedly. Anyway, so we'll get started. So the way today's lab is going to run is that we're kind of going to go through some of the cells together. If you really want cat, it's under tools, then settings, then you go to miscellaneous, and you can activate kitty mode. That's my fun pre-lesson lesson for today. Okay, so the way we're gonna run this is that a lot of this will be kind of like a follow along where you just run the cells, but there are like a few exercises throughout. So for those, I'm gonna give you a few minutes to try them, and then we can work through filling them in together. So it gives you a little chance to actually play with it hands-on. And of course, at any time, if you wanna like play with it further, if you made a copy, you should be able to modify the cells so you can, as I go, play around with it on your own. So for us to get started again, I alluded to that NLP class, and loading it in is pretty easy. So they have a shortcut where you run en, and it runs that en core web small model. So we're running this first cell. Essentially, and you can see it produces the English class, and just to copy steps over, that means it runs all the basic steps. And then I made up a random sentence, and if we put it through the text, the actual like print string will look like the sentence, but it actually is of the type doc. And here's where we start getting to useful properties. So first of all, you can kind of index the doc to know about the tokens. So like you can see here the sentence has 6 words in it. And then you can also index it. So like looking docket 1, it will show you the second word because we're 0 indexing. Of course, that is very basic, but it also starts telling you a few other helpful features. So every essentially token, that's what one word is, has a variety of different attributes. So like .I shows its position in the sentence. The text is literally just the string. And the lemma is the lemma string. So lemma is kind of like a root form of a word. So it's like, for verbs, it's like the first person present. It's the non-plural form of nouns. Like for linguistics, it's helpful to do this, especially because if you're trying to classify something, sometimes it's useful to only use the lemmas, so you have like just a smaller space of things to deal with. So again, let's run this. Then in the next one again, so the next one I'm printing 2 more. So POS, and you have to kind of use the underscore, is the part of speech. So prop N means it's a proper noun, so a name. And then entity type is the type of entity. So here we see that she is a person, Costco is an organization, A is a determiner, and so on. So these are various helpful attributes, and we are going to jump ahead in the exercise, so keep these in mind. So again, and when I'm talking about tokenizing, so splitting things into words, it's not always obvious. Like you might think, like, why don't I just use, like string.split, like a pretty like common Python method, which will just spread everything out at spaces. And that's not necessarily helpful because, for example, if for a sentence I don't like it, you need to actually put the not, so like N''T as a separate word, and SpaCy takes care of that for you. So it kind of goes beyond just splitting on white spaces. And of course, when you deal with like languages that don't use the English alphabet, so like language from various other parts of the world, it's even more important because the tokenization and spacing there doesn't work in the same way. So now we are here, and apparently I'm printing out the answer, but that's okay because I want you to do it yourself. So let me see if I can clear this out. Yeah. So essentially we have a sentence, so I'm going to give you a second to try to pull up which entities are in the sentence, and if you want, you can paste them in the chat if you figure out which entities you see. And this, I'll pull up there was one thing that I wanted to basically show there, which I didn't, so I'll add it now. So if you're curious about the types of named entities, apologies, I thought I linked to this. You can see them at the link, which I'm going to paste here. So if you want to try to decode them, they're here. So let me know if you were able to pull up the named entities you see. Yeah, I'll give you guys a second. I'd say they're prizes for participating, but I just think it's fun. Okay, well, we could really use the code sorry, so I'm sorry, I also didn't realize there might be a bit of a lag. So why does it split at the N and don't? Well, because N''T, it refers to the word not, like, it's a weird contraction for the word not, and so essentially when you're talking about tokenizing, you want to split things into words, which is actually not a trivial concept in linguistics, but it sort of refers to the individual units of meaning. So actually, let's go to the screen, and I'm going to print word.lemma, as we talked about before. So like the lemma NT, but the lemma, the base form there is not. So the reason it splits there is it actually tries to bring things down into individual units of meaning. And in English, the apostrophes create a weird contraction of what is actually two words. Does that make sense? Okay. Yeah. If you please paste. Okay. Cool. Yeah. So kind of going back to my entity type example. So here we actually could paste the code we used right above. So in this case, we see that the first part is a person. Then we have in my sentence geopolitical entity, which just refers to a place. An FAC, which is like a really bizarre acronym, but it's what they use to refer essentially to bridges and roads and stuff. So there's like different types of acronyms, but it's useful to separate out named entity types into different categories. So, okay. So jumping forward a bit, so far we've looked at two things, like tokens, which were single words, which have lemmas and parts of speech, and we've looked at doc, which is the word as a whole. So we had the word doc, Anastasia, which had the type of token, and we had the whole sentence, which had a type of doc. But the third type, which might be actually one of the most useful ones that SpaCy provides, is the type of span. And spans are just like any group of contiguous words that has some kind of special meaning to it. So I kind of had two sentences. So one special thing would be sentences. So under doc.sense, you can split up the words into sentences. So I added up a second sentence about me, and now when you print out doc.sense, each line has an individual sentence. Another one that's useful is, again, those noun chunks, which is really stands for noun phrases. And again, that's what I used for those keywords when I was talking about my introduction. And finally, you can actually print out those entities as one entity. So the fact is, like, named entity recognition usually thinks about the whole name of like a named entity as one thing. So, for example, now it groups together Anastasia Kornilova as a person, and the Rochambeau Memorial Bridge, which I think people just call the Memorial Bridge, is like a whole thing called AFAC, which stands again for bridges and stuff. So I guess now, having that information in mind, and again, I should have gotten it to clear all the cells. Yeah, so now, like, I have another exercise for you to try to use the information I shared to fill this in. So I'm going to give you guys a few minutes to try, and then we're going to kind of ask you to like tell me what each line is so we can go through it together. So I'm going to give you guys like 3 or 4 minutes to look at it. We need like elevator music. Okay, well, let's try to go through this now. So, obviously, at the start of the cell, we have the document, which says there were several black cats, one white cat, and many fluffy sheep in my dreams last night. Then a cat was meowing. So this is gonna be our text. So then we're gonna go through the tokens, because the way you could access them, you can just iterate through them. So did anyone come up with an answer for what you want to put in the first if statement here, where we're checking if the token is cat related? If you have an answer, feel free to paste it in the chat box. This is a very non-threatening environment. Yeah, that is correct. Because we wanted to check the lemma. Anyone have an idea for the next line? Olivia, you were correct. So now we're trying to check the token before the current token. Okay, well, I'll fill this one in for now, then maybe someone else can try the next one. So Slinky says that will be right, but actually I'm on a line earlier, so what we wanted to put here is that we wanted to find the token right before this one. So you're almost right, but we actually wanted to use the I, because the I stood for the position. So this is essentially like, I is like... sorry, 1 second. And then for the next one, you're right about the adjective bit, where we're trying to check for adjective, and essentially, I'm like, sorry. Typing is hard some days. I don't know if anyone else feels that way. So we're gonna check that the parts of speech was adjective. Let's check if we got the outputs. So here we got black and white, so we looked up the lemma, and if the lemma matched, we looked for the word right before it, and then we checked its parts of speech. Sorry, 1 second. Yeah, so I guess, actually, like, I want to check in really quickly, so maybe let me know, type in a 1 if this is really easy for you, or 2 if you want me to go slower, or 3 if you want me to repeat something. So just as a quick check, and maybe give a like 1 if you like the speed this is going at, or 2 if you need me to like slow down and explain things. So okay, great. That's awesome. So, okay, so hopefully by now you understand some of those built-in properties we talked about, like looking at the IDs of things or looking at the parts of speech. And again, referring back to the previous part, this was all done like as a pipeline. So a pipeline is essentially like you run one step, then you pass that to the next step, then you pass that to the next step. And we can look up which pipelines we're currently running under the NLP.pipe names thing. So Tagger did the parts of speech, as I mentioned. The parser was the one that came up with those dependencies, and NER was the named entity recognition step. So like, the automatically built NER stuff is pretty good, but I found that, especially looking at stuff like legislation, there's like certain nuances we wanted to capture that honestly were better served with something like a regex. And like, SpaCy actually is really good stuff for building your own rules. So to do this section, we're going to add in one more pipeline element. And we're going to use an element called entity ruler. So essentially what it does is you would first, I reloaded the model just because it's cleaner. Then when you go to create it, you have to give it the actual NLP object because it needs to know the kind of English vocabulary. That's a little more advanced, but just remember that you have to pass it in. And overwrite entities just means that essentially it will overwrite entities that were processed by the NAR module. So there's like a whole blurb on the SpaCy documentation about it, but for now just assume this is like what we need. So again, here I did very simple. I just literally went, let's check the exact string for JavaScript, because we decided we want a custom type for programming languages. So we're going to add this ruler in, and the key parts is that the label tells you like which entity type you want it to be, and you're allowed to add any new ones you want. So like programming languages is the new one we invented, and the pattern just does an exact string match. So now when we look at our NLP.pipe names, you see we have a new layer called entity ruler. And so then when we run the NLP through it, and we go to essentially print out all the entities we found, we now have a programming language. But then I decided to kind of change the typing, and for some reason it thought it was a person, which both kind of shows that that exact string match was bad, but it also shows that kind of that statistical method fails in these edge cases, and kind of points back to why we're using rulers in the first place. But luckily for us, there's something called lower, which will do kind of a non-case sensitive match, and there's a lot more fancy rules. I just wanted to highlight a couple initial ones. So if we use lower here instead of just using the pattern, we are able to then match this correctly regardless of which casing we use. So I accidentally put the ruler line in Excel here twice, but I guess in a second, like if you want to like try out another programming language, like add a rule for it and see. So give you guys a second to try stuff out with it. So I think a couple of these like cells got repeated accidentally when I was fixing stuff up, so sorry about that. But essentially I just gave you guys a second to try to paste in another pattern. I'll let you guys mess around with that for a second, but then I'll talk about slightly more complex patterns. Yeah, so I think the second cell, which is C++, you can skip that one. I'm sorry for including that in the current version. So I alluded to these more complicated rules, and essentially like there's SpaCy because sometimes rules are not obvious. The people who make SpaCy have actually made kind of like a visual tool where you can debug things. So essentially like the way you do regex is you can match on like uppercase, lowercase characters, symbols, etc. While SpaCy kind of lets you do the same, but now using properties of the words, all these fancy linguistic properties we have. So in their example that loads by default, they kind of have like a 3-part rule. So the first part is like they check the parts of speech, so adjective, and they have a token which says you can use it 0 or once. Then they were trying to match in a lemma, so again, instead of matching on the exact word, like match or matches, they're just matching on the lemma. And they're also checking that it is a noun, because I think matches can refer to verbs maybe, I'm not sure actually. And then they want it to be followed by the lemma B, so kind of using a few of these core properties, namely parts of speech and lemma, and they had a bunch of text they wrote. So as you can see, match is matched because the lemma was match, and is a form of the word be. Then they also similarly had modern matches are, because modern is an adjective, so the op means it matched 0 or once. So essentially this is kind of like a tool that can help you label these things, and it can be very helpful. So kind of again, switching back over, although you might want to keep this window open if you link to it, I have another exercise for you where this time we're going to go back to our adjective plus cats example, and I would like for you guys to try to figure out what the cat pattern would look like. So if you have this window open, you'll essentially end up copy pasting whatever is down here. So I'm going to give you a couple of minutes to paste a match such that black cats and white cat come out. So you'll just add it inside this list, and then when you run the cell, you should be able to see the right output. So I'll give you guys a few minutes to mess around with that. If you're having a lot of trouble, please post about that in the chat. I'll give you guys 2 more minutes, so post the answer if you can figure it out. Okay, about like 20 more seconds, then I'm going to go over the answer. Okay, so I'm actually also going to use the screen we had here just because it's easier. And luckily for us, it's pretty similar to the one we saw before. Really, all we needed to do is take out the last part and switch it to cat. So if we leave here now, at the bottom here, we have our new pattern. So we can take this new pattern and paste it inside the other part. So now when we run this bit of code, we'll actually... I didn't want it op once. Since I wanted like literally exactly one match, I wanted to just do this. So I actually forgot that bit. So the pattern we wanted to see here to kind of replicate that exercise we did before, but in a much simpler form. This was the pattern we were looking for. I'll just paste it in the chat so you have it. And I will later share the lab with everything filled in. So if you don't want to do it now, you have the answers later. So again, entity ruler, the one we looked at, it's like a pre-built component, but really the awesome thing about SpaCy is how customizable it is. So really, you can build a component to do whatever you want. Essentially, it just has to be like a method or a class that when it's called takes in the doc and then outputs the doc back. So we can perhaps, again, let's take a clean copy of the model. And then we can essentially make a class that will just print out the length of the words, which isn't super helpful, but it's indicative. So essentially now when the model runs, it doesn't really change the document, but it does tell you how long the document was. So this might be a very basic pipeline layer. So the second type of kind of useful feature we can get from SpaCy is sort of adding custom attributes. So right now words might have something like an entity type, a parts of speech label, but we might want to further customize it. So SpaCy has essentially logic which lets you set kind of attributes to any token or like span or any document. So if we wanted like it to be really simple, we could just say token.set expansion, and we're going to have one called isTree. And essentially default means that it has this default value. Force just means that when you're running your code, if you try to rerun the cell more than once, it will complain. So when you're writing a program, you probably want to do it when you're first like creating your custom module or whatever. But also there's a lot of different ways to approach setting up custom NLP modules, which we will be able to, feel free to like discuss later. SpaCy actually has an awesome online community. So let's run it. And now we're going to add an isTree attribute. That will be true if something is a tree. So again, that first line means we just use that same copy of NLP from before. And then I isn't a tree, am isn't a tree, but Groot is in fact a tree. So obviously maybe this use case is like, doesn't really make sense. You're like, why would you want to do this? But we actually, one use case that is actually highlighted in the SpaCy documentation or one of the versions is sort of related to prefixes. So the way the natural language processing model in that English model was trained, it currently doesn't keep prefixes as a part of that noun. So if you're trying to extract people's names, you wouldn't get that prefix. So for example, again, let's reload the model, let's run her name through, and this entity will not have that miss prefix. But maybe we want to store it, because maybe we want to do like a full name lookup. So one thing we can do is essentially add an extension for prefix. So we might want to then not change the actual entity model, but we still want to like kind of keep track of the prefix. So we can set an extension called prefix. And then we're going to have a layer which essentially will go through, and when it sees a person entity, check if it has a prefix. So this is going to be like another fill it in exercise, and you would want to fill in the code here, but then to run it and test it, you'd want to run the next two cells. So again, I'll give you a little bit of time to do the exercise, but again, if you'd prefer I don't do the exercise, then just like kind of tell you the answer, feel free to like send some kind of sign in the chat, like if you'd rather have more time for Q&A in the end and not try the exercises right now. I totally understand it, but if you are curious to try it, I'll give you a few minutes for it. And if it's confusing, feel free to also ask a question. I can give some hints. Okay, well, I thought maybe we can just go through the method together, so I know it can be kind of like tricky to just look at random new code. So here is, in this method, we're going to get in the doc, and the doc has already been run through the regular entity recognizer layer, so it will already have people, organizations, etc. And the prefixes here, we're going to assume there's just 3 prefixes total that names can have. So this is going to let us iterate over all the entities. So first of all, like which property of, so we want to find the people. So which property of the people are we trying to check? Like, does anyone have a guess for like what we want to put for this first line? So that's a good guess, but not quite, because entities means we're looking over like all the named entities we already know about. So actually what we'd want to put here is label underscore, and then we're going to check if it matches the word person. So essentially we're like scrolling over the different spans in the sentence, and we want to check what they match. And we're just going to ignore the ones that are at the beginning of the sentence, because they wouldn't have anything before them. And I'll just kind of give you the next one for now. So now that we know this, we want to double check what's going on in the previous token. So end.start was kind of the idea of where this entity started. So we want to actually look at end.start -1, kind of like we did in the previous exercise. So now, like, which property of the previous token do we want to check? Like, so now we know the token, like we know Amelia Earhart, and there's a token before it. So which property of the token do we want to look at? We'll actually just go ahead and look at the text. And finally, well, no, we wanted to look at the text itself, and now we're going to set it as the prefix. But these are all like great ideas, so what we'd actually want to do is copy paste this text. So if we do this now, when we run it, and then on the next line, we're going to go through the entities and check if the entity was a person, and then if it had a prefix, we're going to print it out. So now we assigned it a prefix. So this way we added a new layer we run at the end to deal with the prefixes. So hopefully that mostly made sense. Now it takes a little bit of time to get started. So essentially there's one more thing you could do. Like, you could add it as a prefix, or you could go through and be like, why don't I just change the whole entity to include it? Why do I want to mess with this? So this next bit of code is going to be kind of like what we looked at before. So the first few lines are mostly the same, except now we're going to have a new list of entities. So we're going to again check if we see a person with a potential prefix. Then we're going to look at the previous token and check if it's part of an entity. And then we're going to establish a new span. So spans, as I mentioned earlier, are just like any arbitrary groupings of text. So here we're going to essentially make a span that's going to go from one word earlier this time, since we want to include the prefix, to the existing end of the sentence, and it's going to have the same label, and we add it in. And for all the other base cases, we're just going to add in the entity as is. And then we're just going to essentially reassign the doc to have these new entities. So this time, if we ran it and we looked for all of our... Oops, sorry, I forgot to run the cell. This time we're going to get the whole name. So that is kind of like the main portion of the talk. I have a couple of other fun topics I can cover, but I figured I'd stop now to make sure that if you have questions both about SpaCy or about NLP or machine learning in general, that we can go through them, or I can cover one more bonus theme. So let me know in the chat what you would be interested in. Okay, so one thing I mentioned before is that we were using so far the small like English model, and it's pretty helpful, but one thing it doesn't have is word vectors. And word vectors are like a really big thing in like natural language processing since like 2013, 2014, and essentially it's the idea that when you're doing classification, you can have like a feature for every single word out there, but you'd end up with like hundreds of thousands of features just because there's so many words. So word vectors essentially are a compact representation of every word that's just kind of 300 long. And the way they're designed is that essentially you can use them to compare how similar words are. So there's lots of great material out there right now that I don't have time to dive into, but essentially if you use one of the larger models, I've also shown like an alternate loading scheme here, you actually can have bonus vectors, for the word vectors, for free. So now when we run the document through, the first word has a vector as well as all the other words. So we had 3 words like cat, kitten, and kettle, so at 0, 1, and 2. And so we saw that word 0, cat, and kitten are very similar, but the words cat and kettle are not very similar. So essentially you get these vectors for 3 free, and they also can be run on the whole doc. So you could also get a vector, I'm sorry, that was a burp. You can also get a vector for the entire sentence. So again, you could have one for the sentence, cakes are yummy and desserts are my life. And those two sentences would be much more similar than talking about cakes are yummy and computers are annoying, not nearly as similar. So for various applications, you might want to know, like, if you're dealing with a lot of different text, how similar certain pieces of text are. And vector is a great way to do that. There's lots of other ways to use word vectors, but SpaCy essentially build them in for you as a property. So again, that's kind of the point of SpaCy. It makes a lot of these things very accessible. And again, if you wanted to go further, I linked some links. So I kind of got inspired by, like, there's an actual NLP course that one of the founders of NLP built. So if you wanted to go through the same themes and more, you can follow through that class. They do a lot of similar exercises. And recently SpaCy also launched a big GitHub community. So there's lots of great space to ask for discussions and stuff. So that is kind of what I wanted to cover today. One of the things that I didn't get into is training custom models, which you can do by essentially if you have a lot of text that's kind of more special to your domain. But hopefully you can see some use cases that you can maybe even incorporate kind of into your own projects. Yeah, so that's what I had for today. Again, feel free to ask me questions, even though they're just about, like, careers and data science in general. Always happy to talk. I'll keep this live for like 5 more minutes, and if there's like no questions the next 5 minutes, then I'm going to close this off. Thank you for participating, everyone. I hope it was helpful. Also happy to get feedback on what you like, what you didn't like. Yeah. You're welcome. Thank you. Okay, well, I'm going to sign off now. Have a lovely set of holidays as well.